One of the problems with richer web applications is they tend to result in more network traffic. Web browsers can cache files, but often they still need to make a request to see if something has changed. You need to be able to evolve your application on the server side, and that obviously results in at least one network call being made. One way around this is to use fingerprinting. Fingerprinting is a technique that uses a unique URL for each resource. So you can imagine that your main HTML file refers to a bunch of CSS or JavaScript files, and each of those has been updated to have a unique element to it. This means when your application changes and your main page is refreshed, that new resources can be found, but you can put aggressive caching in the headers so that resources aren't always downloaded. Obviously, you can't just rewrite all of your HTML every time your CSS changes. So Spring offers a couple of new features in 4.1 that can help with this. There are two main classes, resource resolvers and resource transformers. But these are quite flexible systems. We're going to demonstrate here how to use cache busting, but you can imagine using them for any kind of technique. For instance, if you've got a JavaScript pre-processing element, you might use them to find gzip files if that's possible. The resource resolver interface offers two-way resolution between a URL and a resource to serve. So in the classic sense, you might have a URL that you're hitting, for instance, in this case, localhost 8080, and then a particular page.css file with a hash at the end of it. And this is going to resolve by Spring to a particular resource that's inside your jar. So source main resources, static, CSS, page.css. This is very similar to the resource resolving that's been in Spring for a long time. What's new in addition to being able to take a URL and give you a resource is to go the other way around. So given a particular resource, what is the URL that I should use to serve that? So for instance, source main resources, static CSS, page.css could resolve to a fingerprinted version of that includes a hash at the end. The resource transformer interface is used to transform the actual content of files. So in a lot of cases, this might not be necessary. For instance, in your HTML, you may choose to do it a different way, but a classic example is CSS files. So CSS files have @import statements that they can use, which can refer to other CSS files. And obviously, if you're fingerprinting, these also need to be changed. Let's have a quick look at a demonstration where we can do some cache busting. So here I've got an application, and I'm going to build on the Timeleaf example that we did earlier. You can see I've got a standard boot application. I'm using the adapter again, and I've already got that / set up to point to the index file. Let's just have a refresh of what's in that file. I've changed things a little bit. So here I've got the index file, and again that's just declaring that nonsense text. We have the layout file that's importing our JavaScript. In this case I've added some extra stuff, so I'm adding a snowstorm effect to it, which is very retro but very cool. And we have a CSS file, and this CSS file I've also extended because my design team have gone mad and I've got a load of extra files that I need to import. So I've got layouts, emails, widgets, social, pop-ups, all these things that need to come down as well. So if I start this application up, then head over to my web browser, you can see that we get the kind of live lessons. We've got that JavaScript effect that we were talking about. But the important thing is to look at the network traffic. So here you can see we've got a whole bunch of requests that have been made for the CSS files. And these are all kind of straight standard CSS requests. And we're getting a 304 not modified back from the server. So even though we're not sending the content, we're still making a lot of requests. And you can imagine, especially on a mobile website, those requests themselves can take a lot of time. So let's update this application and show how we can add some cache busting to it. The first thing I need to do is add a hook point that tells Timeleaf that whenever it needs to write a URL, it should call our Spring infrastructure to change it first. Luckily, Timeleaf makes use of a standard servlet API, so we can add a filter that will do this. This just replaces any call to encode URL to one that actually adds the Spring infrastructure. So to add that in, all I need to do is add a bean. The bean that I want is resource URL encoding filter. So this is just a standard servlet filter. And Spring Boot, if it sees a servlet filter as a bean, it will wire it up for you. So there's really nothing more I need to do than simply return a new instance of this. So now I'm going to add the resource handler method, an implementation of this that's actually going to do the cache setup. So to do that, I just need to override add resource handler. I get passed in a registry that I need to configure. I'm going to do this only if the dev mode is not set. So I'm going to say if it's not in the dev mode, then I want to set up some additional parameters here. So the registry has a bunch of methods. I need to start by saying I want to add a resource handler and the paths that I want it to handle. So in this case, I'm going to handle pretty much everything. I then say which locations I want it to resolve those resources from. So in this case, because I'm configuring things manually, I need to override the Spring Boot defaults. So I'm going to say I want you to pick things up from the class path, and I want you to use the static folder. Next, I need to tell it that I want chaining enabled. This is just a simple Boolean. And now I can actually start to add my resolvers. I'm going to add a new version resolver. So this is one that takes a resource and replaces it with a particular content in the URL. So it could be a hash or it could be a version. I'm going to use both in this case. With JavaScript files, you often can't use a hash-based approach because the resource loaders that load up those files often need a specific location. So I'm going to use a path-based format there with the version number in it. And then for every other file, I'll append a hash to the end of it. So let's add a fixed version strategy first. So the version that we've got has already come in, so we'll just put that at the front, and then we'll tell it the pattern that we want to use. So in this case, I want every JavaScript file. So this example has added a fixed version resolver, which is going to say all the JavaScript files, I want you to prepend with the version that comes in from the properties file, which you can imagine being set from your Maven POM. Let's add another one that's going to deal with the rest of the files. I'm going to add a content version strategy. Content version strategy just means look at the content of the file and use that to create a unique hash. So this is a great strategy to use for things like CSS files, especially as you may have multiple application versions that get released over a period of time, but the CSS files may remain relatively static. The nice thing about this strategy is the hash will remain if the content remains the same. Here I'm just going to say I want you to map anything that's left to use that particular version strategy. The last thing I want to do is add a transformer. This is an example of an app cache manifest transformer. This means that you can use this code offline. And that should be pretty much all I need to do. Okay, let's restart the application. So now if I head over here and hit return, we should get the same bunch of calls that we got previously, but this time you'll see the URLs are quite different. So for instance, the snowstorm.js file is prefixed with the version. You can see 100 here. And for all the other files, we've got these little hash symbols at the end. So here you've got a long hash that's the unique identifier which represents the content of that file. So if I click the URL again, just hit return, you'll see that this time we don't get any network traffic at all. We just get one call, and because of the aggressive caching that's happened, those URLs that it needs to fetch, the browser already knows about.